test, we say a series of non-negative terms converges if and only if its partial sums are bounded from above. This is a fact. It's a corollary to the theorem 6 actually. So we require that the series is going to have non-negative terms. So it's going to converge if and only if partial sums are bounded from above. So we look at the partial sums. If they are bounded from above, then the series is definitely convergent. If the series is convergent, then the partial sums are definitely bounded from above. The sum of the areas of the rectangles under the graph of f of x, 1 over x squared, is less than the area under the graph. Yeah, if you look at the 1 over x squared, this is going to help you the integral test. This is a nice test. This compares a series with the with an integral. How? Look, let's look at the function f of x is equal to 1 over x squared and consider the area underneath, and then look at these rectangles, some of these rectangles. If you remember, these are the terms of the series, right? As you will see, the areas of these rectangles are the terms of the series, and you are adding them up. So this area, as you will see, is that the total area, blue area that you have seen here, is definitely less than the area underneath the curve, because we have these empty spots here. So the comparison test says, let's say a and b is a sequence of positive terms, and an is equal to f of n, where f is a continuous function, positive decreasing function. Then the series starting from n to infinity and the integral from n to infinity, they both converge or both diverge. If one diverges, the other diverges. If one converges, the other converges. So in the previous example, since we know 1 over x squared from 1 to infinity or 0 to infinity, even from 1 to infinity, to make it easier, 1 to infinity, it is convergent. Then the series that's made up of with these numbers, like 1 over 4, 1 over 9, 1 over 16, 1 over 25, sum of all these is going to be convergent. Okay. Yeah. Right, because how do you say that? You can always shift when you're discussing about the sequence, you can always shift the terms to the right, and your rectangles could be bigger than your f, and then whenever your series is convergent, then your integral is going to be convergent, and vice versa here. Okay, this is the explanation of that. I'm going to skip that.